So today I am presenting the conservation work performed by the Missouri Botanical Garden and its partners in Gabon to establish new protected areas in order to reach at least 30% of the country protected by 2030 and to manage the impact of industrial activities on biodiversity. So firstly, this is where Missouri Botanical Garden has ongoing activities in Africa. So for each country, you have when the activity started, and then you have the main collaborators or funders, etc. So we have activities in West Africa, in Guinea and Liberia, in Central Africa, in Cameroon, São Tomé et Príncipe, Equatorial Guinea, Gabon, Congo. We have activities in East Africa, in Tanzania, and of course in Madagascar. But today I'm only going to present some of our activities in Gabon, which is the country where we have most projects underway in continental Africa. So Gabon is a largely forested country with a very low rate of deforestation. It's the size of Colorado, but with only 2 million inhabitants, mainly living in urban areas. And it therefore has the most intact forest ecosystems in tropical Africa. So the country has currently 32 protected areas, representing 60% of its land and 26% of its ocean area. And since 2 decades, the Gabonese government has a strong political commitment towards the development of a green economy for the country. And for instance, Gabon was the African leader for the negotiation of the 30 by 30 objective during the last CBD. So this objective is to protect 30% of the earth by 2030. And each signatory country of the CBD has accepted this principle and must implement it at national scale. So Gabon is one of the few countries in the world, I think, at least in tropical areas, where in situ conservation is being implemented and has become a key component of the national land use planning. Missouri Botanical Garden has been leading research and conservation activities in Gabon since 1983 through a MOU signed with the National Center of Research and Technological Research, Scientific and Technological Research, and has closely worked with the National Herbarium of Gabon ever since. So the in situ conservation work done by MBG in Gabon is based on a long and extensive collaborations with scientific institutions, conservation NGOs, but also Gabonese governmental institutions, and also industrial companies, and is grounded on international conservation standards, such as the red list of species, more recently key biodiversity areas, high conservation value from the Forest Stewardship Council, and also the PS6 standard of the International Finance Corporation. And of course, all these stakeholders are closely interconnected. And together, we're trying to develop innovative processes and tools to facilitate Gabon in situ conservation policies and actions in order to achieve the 30 by 30 target. So now I'm going to present some of the activities led by MBG in Gabon during the last 5 years. So first, we focused on tree and forest ecosystems to implement in situ conservation actions. And this was done through a project funded by the Franklin Foundation that started in 2020. And the first thing was to identify what are the tree species of Gabon and to determine which of them are threatened. And to do so, we use an automated computational workflow in the R environment called CONR to identify the threatened plant species according to the criteria A, B, and D2 of the IUCN Red List. So here are some references about this methodology. And so we find that 300 potentially threatened tree species were in Gabon were not yet assessed on the red list at the beginning of the project. So we identified the risk of extinction, and we published them on the red list. And in the same time, we collaborated with BGCI, which assessed the potentially non-threatened tree species in order to achieve the global tree assessment objective of having all tree species assessed on the red list. Finally, we identified the 100 most threatened tree species of Gabon, so basically the critically endangered and endangered ones. Sorry. So one of these species is Aristogetonia gabonica, a small tree from the Pygrodondraceae family. And this species is only known from one locality in the Libreville surroundings. So Libreville is the capital city of Gabon. This species lives on calcareous rocks in forest just behind mangroves, and this is a very restricted habitat. And in 2016, this species was assessed as critically endangered because its habitat is very threatened by the expansion of Libreville, but also shift agriculture and sand quarrying. And the population of this species is therefore declining. So we estimate that the number of mature individuals of this species is probably less than 500 individuals, mature individuals. And this species is therefore probably the most threatened tree species of Gabon. So last year we collected for the first time seeds of this species. So we have one collaborator that was there when it was fruiting. So we have for the first time pictures of the fruits, and we are growing these seeds in a shade house in Libreville in order to do some ex situ conservation for the moment. So here are these seeds growing. And this year, we will try to assess the population size and population distribution of this species in order to improve the conservation actions we propose. All right, so during this project, we also collaborated with an NGO called Nature Plus in order to assess the 20 most exploited timber tree species in Central Africa. And to do so, we developed a new methodology to assess this species against the criterion A of the IUCN Red List, and in particular to infer the projected population reduction of this species over the next century. So for each species, we estimated the generation time, so that is the average age of their mature individuals of the population, and also the population distribution and population size. To do so, our partners compiled forest inventory data from more than 20 million hectares in Central Africa. So that represents 22% of the total forest area in Central Africa. And he quantified the reduction in population size due to logging, in taking into account mortality, recruitment, tree growth, and logging levels. And last year in December, we coordinate a workshop in Libreville to validate these results and submit this assessment to the Red List. All right, so during the second step of the project, we also identified ecosystems that are restricted, that are range restricted, that are threatened by anthropogenic activities, and in which certain species occurs. And to date, so we use a methodology that mimics the Red List of ecosystem criteria. And to date, we identify 10 threatened ecosystems for the country, and one of them is a hyper-humid coastal forest in the surrounding of Gabon. So you can see it on the map here. So this ecosystem contains 18 plant species endemic to these ecosystems, 70 plant species are endemic to Gabon and more than 80 plant species that are threatened. And during the last century, this ecosystem has been reduced by 85%. So in this map, you can see the remaining part of this ecosystem in green and all the lost part in red. So this is also probably the most threatened ecosystems to collapse in Gabon. And in these ecosystems live also the tree that I presented just before. Okay, so all this information I have presented so far are currently being compiled into a booklet designed to inform industrial companies and governments about the existence of threatened plant species that we would like to be protected nationally, the presence of threatened ecosystems, and in order to set up new conservation areas for the country. All right, so based on the information on threatened tree species and forest ecosystems, we try to define conservation action plans for the 100 most threatened tree species. So because it takes too long to make a conservation plan for each species, we use a methodology developed by the conservation planning specialist group called Assess to Plan in order to do multi-species conservation action plans. So the principle is to group species that share overlapping conservation needs. So for instance, you can group species by threat or habitat, and then you define a joint measure that will improve the conservation of all the species of the groups. And species can appear in different groups. So then you build your conservation action plan, so it's looking like this, and in which you find not only what action is needed, but also by who it will be done, when, and with what resources. And to date, we have identified 13 groups, so we have designed 13 action plans. And the next step is to sit down with all the stakeholders identified and agree to what we want to do, what is needed, and start implementing these conservation actions. So we are currently also working on building an Excel-based tool to facilitate the creation of conservation action plans. So basically from a dictionary of conservation measure and species, dictionary of species, you will be able to create multi-species or species-specific action plans with just a few clicks. So you will have just to build your dictionary. And of course, when it will be done, I will share this information because I know that in the garden a lot of people, and I'm thinking in particular the Madagascar team are working on these things, and so we will present the tool as soon as it's ready. All right, so a part of this Franklinia project, we are also working with industrial companies to identify conservation and offset areas through high conservation value and PS6 standards, so from the IFC. So basically what we're doing is to do botanical inventories in these concessions, and then we identify threatened plant species and ecosystems, and then we propose conservation or offset areas. And during these last 5 years, more than 1,000 square kilometers have been set aside for conservation in various concessions in Gabon, and a new protected area has been created. All right, so we are also creating tools to facilitate conservation policies and actions, and the one I would like to present in particular is CONAP. So, but I will stop the presentation and I will try to do a little demo of this application. So, but I have to move So all right. All right. So this app was designed to either you can identify potentially threatened plant species from a given site. So it's one module here. You can get information on threatened tree species in Gabon with updated map because the data of plant occurrences will come from GBIF. Or you can conduct preliminary multi-species assessment risk of extinction risk under the criterion B of the ICN red list. So first, let's imagine you are a consulting firm that have to do an impact study, and you want to know if in the sites to be impacted there are potential plant species that are threatened, and before going to the field. So you can use this model. Or you can think also if a government receives an impact study from a consulting firm and it wants to check if the work has been done properly, so it can also use this model. So let's go. So first you need to give your study area. So you can either draw on the map your study of interest. Can zoom, and you can draw something, but I won't use that now. Oh, sorry. Or you can read the shapefile. So let's do that. Test. All right. So you have to know that for the moment the app is designed mostly for Central Africa, but we want to upscale it to the whole continent and then perhaps the whole world. All right, so you have your site. It's here. It's okay. It's doing things alone. So, but basically it retrieves the occurrence data from the Rainbow database, so, which is a database of tropical of occurrence from tropical Africa. It's a verified database, but the limit it's not updated regularly. So soon we will also be able to, in this module, to retrieve data from GBIF. Okay, so in the site that I've uploaded, there are 17 species in the site. And it retrieves the data from all the global distribution of these 17 species. So there are 2,000 occurrence data for these 17 species globally. So you have access to the specimens, and then you continue to go to assess it, and you just launch the analysis. So it's assessing under the criterion B. So it's a geographical distribution. Okay, it's already done. And once the results appear, so it gives you some basic parameters of criterion B. So extent of occurrence, area of occupancy, number of locations, and to calculate the number of locations, we implemented in the application some threat layers in Central Africa. So cities, urban area, agricultural areas, logging concessions, mining permits, etc. And with that, it's the way how we do red listing in Central Africa. We use these layers and we calculate the location according to this layer. So it calculates approximately a good does a good assessment of number of locations, and then it gives you an IUCN preliminary assessment category. So value, and you have also some other characteristics. So it identifies the main threat for each species, and it gives you the number of locations considering each threat layer. We also implemented the layer of protected areas, and it tells you if it's range restricted according to the PACE 6 standards. So all the species that have range less than 50,000 square kilometers. So you can download these results. So you can download this table in an Excel sheet. But you have also access to a summary report. So it will take just a few seconds to build it. All right. And you can also download the reports. The good things by downloading these reports is you can still have access it offline. It's a .html, and you can also access it offline, and you will see there is an interactive map. So when you access it offline, it's still interactive. So you have access to all the data. So in this site, we have one potentially endangered species, one vulnerable species, etc., etc. All right, so you have your data that if you want what are the EN species or VU species, you can filter them out. And it's not easy here, okay. And then it's big. And then you have an interactive map where you can zoom in, zoom out, and you have data of the species. So in this map, it appears only the threatened species. And that's it. And you have also summary reports by species. So if you want some report only for one specific species, you have it here. Let's wait a bit. Bit longer. Come on. But okay, let's in the species report. It's okay. You have the a map as well. You have also the characteristics, but you have a map of the global distribution of the species. And on the map, you can remove the, I don't know, protected areas, logging areas. So you can play with it. All right, so go back to first page. So now let's imagine as a scientist, you want to assess one species or multi-species under the criterion B of the red list. So the third module is for you. All right, so you can retrieve occurrence data either from GBIF or Rainbow. It's the same thing. Or you have this polygon things that you can draw or just upload a shapefile. Or you can upload your own data set of occurrences. So let's try to do from GBIF. So I will write just some species, Gabonese species. If anyone in the room has a species he wants to test, anyone. Palisota steverti. Good one. All right. Okay, so it found the 3 species in GBIF, and then you click to import occurrence data. So let's wait. Right. So then you go to, sorry. Yeah, it's still collecting. Actually, it's collecting spatial data from the threat layers because it already upload the occurrences, so it is looking at what are the layers that overlap the distribution of the species. So you go to variable selection. So in case of GBIF and rainbow, the variables that you need to decide to put in the analysis are already pre-selected, but it's just drag and drop. So, but basically you need at least the species, the taxon name, and the longitude and latitude of species to assess against the criterion B. But you can put any things you want. And then you have automated checking of some parameters. So it checks if there are geographic coordinates out of range. So we are working in decimal degrees, so more than 90 for latitude or etc. So it's not working. And then they remove it's removing these occurrences, these lines. It checks also if there are scientific names or empty geographic coordinates. And so it works also with your own data set. So then you can display or download the problematic rows. So just let him display. And so like this, you know which lines doesn't work in your data set, for instance. And at the end, you have, just invalid year. It's just because it doesn't have a year of collection, but it's not removing the occurrence. And then you have a mapping tool. So let me remove this. Okay. So you have it display the distribution for all your species, but you can select only one species. For instance, Palisota stevarti. All right. So it looks good. Or I will choose that one because you have also the possibility to remove some occurrence you know to be incorrect. So for Ocomia cliniana, it's a tree growing in Central Africa, so it's almost subendemic to Gabon, and we know that the species do not occur naturally in West Africa or in Madagascar. So if you want to remove these occurrences, you have a tool here to cancel, either by a square or any shape. You select them, and there is a problem here. Because I think it's because of the size of the screen. Because we have another module here just to remove these occurrences that have been selected. It will appear on my computer, but it's not appearing here. Sorry for that. And all right, so it's a tool, And you can also display the threat layers, like the logging concessions that overlap the distribution of the species, protected area, etc., etc. And you can remove some threat layer that overlap the distribution species if you don't want to take them into account in the analysis. But we don't want to do that. And it's the same thing. So you are on the analysis module. You have some parameters that you may change if you want, but these ones are the default ones are the one used by IUCN. So, but if you want to change some things, and we have our results. So go to summary reports to see. No, sorry, I did a small mistake. It's in process. Now, because actually you have the possibility to launch the analysis only for one species, it's what I did actually, or for all species. But yeah, that's okay. So you will discover this app soon, I hope. So I think I will finish with this presentation of the app. Sorry. Where am I? Ah, yeah. Okay, let's go back to the main presentation. All right. So let me just shrink. So for the Franklinia project, we also set up a Tropicus project entitled a certain plant species in Gabon, where you can find the information about the threatened species and threatened ecosystems we have worked on so far. But you will also find some additional information like the country's endemic and subendemic plants, the country's tree species, also some information about the conservation projects we are working on, and also you have access to all the African program newsletters of the garden. So if you're interested in our activities. All right, so finally, we are working on the identification of key biodiversity areas for Gabon. So it's a methodology developed by IUCN in 2016, and it aims at identifying sites that contribute to the global persistence of biodiversity. This methodology has been explicitly recognized during the last CBD as a tool to identify the next protected areas to achieve the 30 by 30 target. And basically in this methodology, you have to use all the data, all the taxonomic groups for which you have data. So fauna, flora, fungi, but also ecosystems, and even the genetic specificities of species. And then you have to assess which sites on land, underground, in oceans are relevant for the persistence of global biodiversity. So this methodology is based on thresholds and criteria that are standardized globally for all taxonomic groups. And the KBA implementation process in Gabon started in 2020. In 2021, we did the first KBA methodology workshop in Libreville through the Franklinia funded project. And a month later, MBG was chosen by the KBA Secretariat to coordinate the KBA identification at the national level through a project funded by the Brothers Earth Fund. And this fund is managed by BirdLife International. And this project aims at identifying KBAs in 7 countries, 4 in tropical Andes, so Bolivia, Colombia, Ecuador, and Peru, and 3 in the Congo Basin, so Gabon, Republic of Congo, and Democratic Republic of the Congo. And in order to identify these KBAs and to include them in the national land use planning, we created a national coordination groups with the scientists, but also with all the government bodies that are related to land use of the country. So a lot of ministries and a lot of also national agencies like the National Park Agency, etc. But we also included universities, NGOs, and representatives of local populations. And we are currently trying since a year now to formalize this entity by a decree. So after 1 year of this project, more or less, there are already 2 great achievements, I think. First one is KBA is already seen by the government as a land use planning tool for the country. So I think it's very good because they want to use this tool to make the planning of their land. And the second thing is that for the first time ever in Gabon, botanists and zoologists are working together. We are sharing data, we are sharing results, and to identify the next protected areas for the country. So it's a major step forward for conservation in Gabon. So to know, for you to know, it's we have currently 13 national parks in Gabon on land, and this one have been designed in early 2000, but this was mostly, they were mostly identified through faunal data. So the presence of threatened big mammals like elephants, gorillas, and flora was not taken into account at that time. Because, yeah, at that time we didn't know what were the threatened plant species and endemic ones. But since 5-10 years and the MBG activities, we now know that. And we have the chance to use this in this project to make the next protected areas for the country. So we are currently working on 40 sites that we are assess as to know if there are KBAs or not. So 20 sites that match current protected areas. So we are testing if protected areas can be considered as KBAs. Also 5 sites that have already been identified by the government as potential future areas for the country. And also 14 sites that us, botanists, zoologists, have identified as the most important for flora and fauna. And the thing is, for flora, it's mostly based on flora first, and we use the results of the Franklinia funded project, so the presence of certain tree species to identify these sites. So to date, we have worked on 14 sites, 3 marine and 11 terrestrial sites. It's a long work, it's a hard work to do. And to speed up a bit the analysis for flora, I have written on Earthscrap to automate the identification of potential trigger plant species for KBAs. So it's a bit easier, I would say. And to date, 60 trigger plant species have been identified as trigger elements for these 11 terrestrial sites. But for these sites, we have also over 100 potential trigger plant species. We have not checked them out because of lack of time. But the important things to note is for these 14 sites, flora represent 44%. So it's the main component of trigger elements for KBAs in Gabon, even when we consider marine sites and when we didn't check all the potential trigger plant species. So it's a very important part of KBAs. All right, so now just some issue and perspective about this project and for conservation in general in Gabon. So to date, only 40% of plant species are already assessed on the red list. So that means that a lot of threatened plant species are not yet assessed on the red list. And once this work will be done, so we will have the possibility to assess more sites for KBAs under one of the criterion, but it will also oblige industrial companies to use them for when they measure and manage the impact of their activities. So assessing the extinction risks of plant species in Gabon, I think is one of the priority for conservation for the country. And similarly, the identification of ecosystems for the country is really at its beginning. And so the next step will be to map all the Gabon's ecosystems, to assess the risk of collapse, and to assess and to publish their assessments on the red list of ecosystems. And this will, of course, I think, really facilitate to lobby, to make lobby towards the government to conserve this threatened ecosystem, like the ones around Libreville. All right, so what can we learn from all this work is to make effective biodiversity conservation, you have several steps. So first, you need to know your conservation needs. And the process of identifying threatened plant species, collapsing ecosystems, identifying key biodiversity areas is a good approach to do so. 2, you need to share information, data, results to a maximum of people. And you need to build tools to facilitate conservation policies and actions. And 3, if you want to implement your conservation measure, you need to have an interconnected network of stakeholders, and you need to consult them regularly and try to make decisions together. And finally, what I have not talked about is the necessity to build capacity. So in Central Africa, it's one of the greatest needs raised by scientists and governments. So we are doing such a job. We are training parataxonomists and students through a master and doctoral thesis, but I don't think it's enough because we all agree that we need more local botanists and more trained students. And the last thing is you also need to involve the people that are impacted by your measure. So you need to involve local populations in particular. So it's things that is not easy to do, but we have to try to go this way. All right, so thank you for your attention.